These are some concepts you need to remember about inverse functions. Let's start with their graphs. First of all, the coordinates of all the points are reversed. So for example, if the point 5, 1, which I have here, is on a graph, then its inverse function has the point 1, 5. Or if the point 4, 0 is on the original graph, then the point 0, 4 is on the inverse graph. So if you're given a function and you're given its graph, you can find coordinates of certain points and then just reverse those coordinates and plot the inverse. Another important thing to remember is if the original function has an asymptote, so in this case my original function has an asymptote here at the line x equals 3. So that means my inverse function has to have an asymptote at the line y equals 3. Notice that in general, the inverse is a reflection across the line y equals x. So the graph just reflects across that line. Now, as a consequence of these other characteristics, the domain and range are also reversed. So if you look at the blue graph, the domain of this is that x has to be greater than 3. So in the blue, the domain is that x is greater than 3, or 3 comma infinity. The range is all real numbers. Now I've drew that dotted red line, but that doesn't pertain to the blue graph. So this blue graph is continuing to go up and up, and it's continuing to go down here. So if I were to continue this, okay, it's still going to go up and it's still going to go down. So it's going to be all real numbers in the y direction. Now if you look then at the red graph, the domain of the red graph, x can be all real numbers because it's continuing to go this way and it's continuing to go up and to the right. So if we went way over here and we went far enough up, we would still find a point that has any x coordinate. So its domain is all real numbers, but its range, you can see, is only values of y that are greater than 3. So 3 comma infinity. Now I want to look at this parabola, and let's just apply what we've learned to this parabola. So here's the point 2, 1, so the point 1, 2 would be on the inverse. Here's the point 3, 0, so 0, 3. 0, 3. And here's the point 1, 0, so 0, 1. And let's see, let's find a couple other points. 1, 2, 3, 4, 3. So the point 3, 4. Okay, I'm going to pause for a second. You're probably all crying foul here. Let me try this again. And I'm going to put these in different colors. This is the point 2, negative 1, so it would be negative 1, 2. There we go. I knew this wasn't looking right. And then we have 1, 0, and 3, 0. So we have 0, 1, and 0, 3. We have 4, 3. So we would have the point 3, 4. We have, let's see, anything else that I can find that's real easy. Anyway, basically we're looking at this graph here. Okay, so here's my inverse. And notice it reflects across the line y equals x. This isn't a terribly greatly drawn graph, but it looks basically like this. Now the problem is with this graph, the graph of the inverse is not a function. Notice that in this inverse graph, this black graph here that I drew sideways, each x can pair with more than one y. So we have a problem here. So this function, this is when we're talking about invertible or one-to-one functions. I'm going to erase this for a second. My original graph is not one-to-one. Each x pairs with exactly one y, but each y pairs with more than one x. So it's not considered a one-to-one function. Therefore, its inverse is not a function. So what do? Well, we have to look at only one half of the function, either the right half of the function or the left half. So let's just look at the right half of the function. This is the function for which x is greater than or equal to 2. So if I took that domain restriction and said, let's just say that x is greater than or equal to 2. I'm going to write this over here. Then I'm only looking at values that are going to give me, I'm only going to be getting the right-hand side of this graph, so I'm only going to be getting, when I do the inverse, the upper side of the inverse. So I'm only going to be getting these points right here. Let's see, we had 4, 3, 3, 4. So I'm only going to be looking at this for the inverse. Okay, and you can see that the red graph and the red shaded part of the graph and the blue shaded part of the graph are inverses of each other. So sometimes you have to limit the domain of the original function in order for the function to have an inverse. Now, if I were to do the left-hand side, then I would be using, and you can hopefully see that this is a square root graph, it would be the negative square root. So how do you go about finding an inverse function? If you know an original function, how do you find it? How do you verify that it actually is a function? So let's take this value, f of x is equal to x minus 2 squared minus 1. And let's look at how we can find the inverse function and verify that it is an inverse. One way to find the inverse function is to actually switch the x and y. So let's replace the f of x with a y. And make sure that you do replace it. It doesn't just disappear. It is there. It is a y value. Let's switch the x and y. So we have x equals y minus 2 squared minus 1, and solve for y. So the first thing I would do is add 1 to both sides. And then I would take the square root of both sides. Now when I take the square root of both sides, it's either the positive or the negative square root. So in this case, I'm going to want the positive square root. If I used, since I'm saying that x has to be greater than or equal to 2, and I'm using the right-hand side of my parabola, I have to use the positive square root. If I was saying x is less than or equal to 2, I would use the negative square root for my inverse. So I have the square root of x plus 1 is equal to y minus 2, or the square root of x plus 1 plus 2 equals y. So I have f inverse of x is equal to the square root of x plus 1 plus 2. Now I want you to notice a couple things about these. If you look at how we've done things to x, here we start out by saying, let's subtract 2 from x. Then let's square it. Let's square the quantity. And then number 3, let's subtract 1. Now let's see what happens in the inverse function. The first thing I do is add 1 to x. The second thing I do is take the square root of that quantity, and the third thing I do is add 2. Notice that I do the opposite operations, because the opposite of, or the opposite operation or the inverse operation to subtraction is addition. The inverse of squaring is square root. The inverse of here, subtraction, is addition. Notice I do the opposite operation. I also do them in the opposite order. Here I end with -1. Here I start with adding 1. So these verify that these are inverses. Another way to verify that they are inverses is to put a number into the function. And I'm actually going to start by putting a number into the inverse function because it's easier to pick a nice number for the square root here. So I'm going to say f inverse of 1. I'm sorry, f inverse, let's say f inverse of 3. So f inverse of 3 is equal to the square root of 3 plus 1 plus 2, which is the square root of 2, square root of 4, which is 2. So this ends up being 2 plus 2 is 4. So f inverse of 3 is equal to 4. Now I'm going to take 4 and put it into the other function. So f of 4 is equal to 4 minus 2 squared minus 1, which is 2 squared minus 1, which is 3. So f of 4 is equal to 3. So notice here they undo each other. If f inverse of 3 equals 4, then f of 4 has to equal 3. That shows also that they are inverses. One more way of showing they are inverses, and once again, this is, I have limited this to x greater than or equal to 2 in order for them to be inverses. Another way to show they're inverses is called composition of functions. So I'm going to take the function, so let me rewrite my function. F of x is, I better see what it is, x minus 2 squared minus 1. F inverse of x is equal to the square root of x plus 1 plus 2. And remember, this has the restriction that x has to be greater than or equal to 2. If I do f of f inverse of x, meaning I take the entire f inverse function and substitute it for x right here, I get the square root, or in parentheses, x plus 1 plus 2, and then I have to do the minus 2, which is right here. Okay, so minus 2 squared minus 1, which gives me x plus 1 squared, because plus 2 minus 2 cancel out, they add to 0, minus 1, which gives me x plus 1, the quantity squared is x plus 1, minus 1 is x. So if f of f inverse of x equals x, or f of inverse of f of x, f inverse of f of x equals x, they are inverses. Okay, so that's another way to check, called composition of functions. So those are some important things you need to know about inverses.